Hello guys, welcome to the Unit 8 Lesson 1 notes on factors. And guess what? This is literally one of my favorite things in the whole world. I'm so excited to share this factor knowledge with you. By the end of the day, you will be able to find the greatest common factor of a number or a monomial or a set of numbers or, whatever. By the way, greatest common factor, if I ever talk about the GCF, that's what I'm talking about. Just so you know, a factor, we're going to talk all about factors today. A factor is the thing that you multiply. So if you have like something times something, the things you're multiplying, we call those factors. And then the result is the product. For example, 12 here. 12 is our product because here we have one factor of 1. And then we go 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops. Did I count that right? That's not even 12, is it? Come on. What talk about struggle? 2, 4, 6, 8, 10. Oh, yeah, no, okay. It is 12 wide because we say that 1 times 12 equals 12. 1 times 12 equals 12. So 1 and 12 are factors of 12. But guess what? Look, there are 12 squares in here. This is a 2 by 6 area. Okay? And this one is a 3 by 4 area. But 3 by 4 is still 12. Okay, so the product is 12. The factors are... Oh, hey, look, the factors of 12 are 1, 2, 3, 4, 6, and 12. Notice also that factors always come in pairs. You have to have something times something to get a number. So you can check to see if you have all the pairs by drawing these rainbow guys, this rainbow connection. 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. They always come in pairs sometimes. I take that back actually, because if you have like 9's factors, that's 1, 3, 9. You can still draw your little rainbows because 1 times 9 is 9, but 3 times 3 is 9, so it's like a rainbow on itself. Yeah. Okay, next. Numbers with exactly 2 factors, we call these guys prime numbers because they're the best. Prime numbers, 2 factors are going to be 1 times whatever that number is. Numbers like this, we've seen them before, are 2, 3, 5, 7, 11, 13, 17, 19, 23. I could go on for literally forever, but I will not. So, yeah. And then not prime numbers, that is numbers with more than 2 factors. We call them composite because they're composed of multiple numbers. For my Spanish people, like compuesto, poner is to put, con means together. You put them together, composite numbers. And these are basically not prime numbers. So, you've got 4, 6, 8, 9, 10, 12, 15. I skipped 14. But, yeah. All even numbers are composite numbers, except 2. And then just because these definitions, they're defined by the number of factors. How many factors does 0 have? It gets kind of messy. How many factors does 1? That's a 1. Does 1 have? It gets kind of messy. So we just say they're neither prime nor composite. Yeah. Hey, let's jump right in. Now that we have all those definitions out of the way, we need to find all of the factors. Notice we're not prime factorizing them. We're not going to draw factor trees. You can. If it helps you to draw a factor tree, you can. Let's do one. Let's draw a factor tree and I'll show you how that No, it's going to get too messy. Okay, so let's go through all the numbers. 72 is divisible by 1. Is it divisible by 2? Yes. Is it divisible by 3? Yes. Is it divisible by 4? Yes. Is it divisible by 6? Yes. Is it divisible by 8? Yes. By the way, as you're going, sometimes it helps to immediately draw the rainbows. So 72 is divisible by 1, because 1 times 72 is 72. And then 2 times 36 is 72. And then 3 times 24 is 72. And, oh, I need to make these a little skinnier. I ran out of room, guys. So sorry. 4 times 18 is 72. 6 times 12 is 72. And 8 times 9 is 72. So there you go. They're all connected in little pairs. Looks like a boat. Let's do it again. Always start with 1. So 23 is 1 times 23. Oh, we're done. So we would say 23 is prime because it has only 2 factors. Oh, and that makes 72 composite. Because it's not prime. Okay, 37. Well, let's start with 1. 37 is 1 times 37. Cool. But that's it. That's the only thing. It's not divisible by 2, 3, 4, 5, 6, 7, 8, 9, 10. No, none of those. So it's prime. Okay, 10. It's divisible by 1 and 10, 2 and 5, 3, no, 4, no, 5. Oh, hey, look, 5. We're done. Cool. So that makes it composite because it is composed of several different numbers. Okay. So you'll remember a monomial. A monomial is something with one number. It's like one term. It's a whole bunch of things multiplied together. We say that a monomial is in factored form when it's expressed as a product of its prime numbers, its prime factors, and variables with no variable with the exponent greater than 1. That's super abstract. I'll just show you. So 15, if we want to factor it, now it's time to do factor tree. Factor tree, do. Okay. So 15 can be split into 5 times 3, and these are both prime. Now, I like to list my numbers from smallest to biggest, so I'm actually going to say that's 3 times 5. A is just A once. Should I make this whole thing green? I think I'll just make this whole thing green, so you can see where these ideas are coming from. A is just 1A, so times A times, and then B squared, that tells us we have 2 B's. So we have B times B. So this is factored form right here. We have 3 times 5 times A times B times B. Done. Okay, now let's check. Do we fit? We have only prime numbers, and each variable has an exponent of 1. Okay, cool. Oof! Check that, negative. Think of the negative as -1. So we'll start out with -1 times, and now we need to find out, okay, what are the prime factors of 84? When I look at 84, I think I can split him up into 4 times 21. 4 I can split up to 2 times 2. 21 I can split up into 3 times 7. So look at all those guys. Those are all equal to 84. So we get 81 is 2 times 2 times 3 times 7. Sweet. Now let's split up this y to the cubed. No. Y cubed is three y's all multiplied together. So it's y times y times y. And how many z's do we have here? Don't get too lazy. We just have one z. So the prime, not prime factored, the factored form of this whole expression is 1 times 2 times 3 times 7 times y times y times y times z. That's cool and all, but what is the point? This seems like we're working backwards. It's like we're trying to come up with an essay and we need to get a word count, so we're just super stretching it out, which is not recommended for essays, by the way. But writing numbers in factored form is especially helpful for finding what's called the greatest common factor. And we abbreviate it GCF. So from now on, I'm going to say GCF because that's a lot easier. So the GCF of two numbers is the greatest number. That means the biggest number. That's a factor of both original numbers. It's the biggest factor they have in common. So it's the greatest common factor. Crazy, right? Well, how do you do that? Well, you factor them both and then you see what they have in common. Okay. Shooties my goodies, I spelled this wrong. It should be GCF. There you go. Find the GCF of each set. Okay, so to find the GCF, first look at factors. F stands for factors. So you need to factor them out. So the GCF of, or rather, the factors of 75. 75 we can split into 25 times 3. 3 is prime. Cool. 25 isn't, so that's not prime. Okay, so 75 we can write as 3 times 5 times 5. Awesome. And now we need to figure out, okay, what are the factors of 100? The prime factors of 100, rather. Well, 100 is 10 times 10, so that's lovely. And 10 is 2 times 5, which are both prime. Oh, but guess what, guys? Did you know that 10 is 2 times 5, which are both prime? Crazy. So that means the prime factorization of 100 is 2 times 2 times 5 times 5. Ta-da! And now that we have the factorization, we need to figure out what do they have in common. That turned out funky, but that's okay. What do they have in common? And some of you guys you can easily see this. You can just be like, oh, they each have a 5 and they each have another 5. And if that works for you, that's great. If you, like I am, need to be a little bit more organized, you can always line them up, which requires you to do a little bit of spacing out a little bit. So you need to line them up so that you have, like this. So the factors all line up together. And that enables you to see really, really well, really clearly what they have in common. So it's a lot easier to see, oh, they both have a 5 in common. They both have another 5 in common. They have 2 5s in common. Ha ha ha. So you can see we still got the same results. So they have 5 times 5 in common. Okay, but guess what, guys? We need to now find the greatest. What is the greatest common factor of all time? The GCF, go. No, I know. Okay, right? So what we do is we multiply them all together. 5 times 5 is 25. Or if you want to get super pedantic, the way we write this is we say the GCF of 75 and 100, that's a comma, equals 25. This is like the math equivalent of writing your answer in a complete sentence. Okay, there you go. So how do you find the greatest common factor? Well, you find the factors, and then you find what they have in common, and then you look at the greatest one, which is multiplying them all together. Fun, right? Let's do it again. Oof, look at this guy. Okay, let's put the F in GCF by finding the factors first. That'd be fantastic. Friends. Okay, anyway. So first let's factor 24ab squared. 24, I'll split up into 8 times 3, and then 8 is 2 times 4, and 4 is 2 times 2. So we end here, giving us 24ab squared. Oh, I lied. No, I'm just kidding. 24ab squared is 24, which is 1, 2, 3 2s times, that's a 3. We have 1a and we have 2 b's. B. Yay. Okay, and then 60 a squared bc. We need to prime factor 60 real quick, so I'll go ahead and do that. 60, when I see 60, or rather any number ending in 10, or in 0, I think 10. So I do 10 times 6. 10 is 5 times 2. 6 is 3 times 2, so they have at least, oh well, I mean, those two have a 2 in common, which is great. So 60 then gives us 2 2s. Put on your ballerina. 2 2. So that's our 60. And then we have 2 A's, a B, and a C. Yay! We've got the factors! Now let's find what they have in common. If you want to align them, that's fine. If you want to just reach out and say, hey, look, they have 2 2's in common. They have a 3 in common. They have an A in common. They have a B in common. And that's it. Okay, cool. So let's put them all together. Their common factors are 1, 2 2's, a 3, an A, and a B. So multiplying that all out, 2 times 2 is 4. 4 times 3 is 12. So we say the GCF, the greatest common factor of 20, you know what? These guys the greatest common factor of these two is going to take up more space than I have. 12ab. Awesome. GCF, the greatest common factor. Isn't that great? So fun. Okay, well, that's it. That's literally it. And it's one of my favorite things, finding GCFs and finding prime factorizations. And it's great. So I hope this factors into your life. Yes, remember to find a greatest common factor. First, you need to find all the factors. And then you need to look at what they have in common. And then you multiply them all together. But also have a great time on your homework.